Hello and welcome to this video. In this video we will solve 31st set of problems on quadratic equations and polynomials. That is question number 301 to 310. I have fixed the typing mistakes up to problem 300. So without further ado, let's get started. The link for the PDF will be given in the description of the video. So question 301 says that find the values of p and q such that the equation x square plus px plus q is equal to 0 has 5 plus 3i as a root. So this is a complex root, therefore it will occur in pair. That is, if one of the roots is 5 plus 3i, the other would be complex conjugate, that is 5 minus 3i. So we have two roots, the sum is 10 and product is 34. Therefore, the equation will be x square minus 10x plus 34 is equal to 0. Question 302 says that form the quadratic equation whose one root is 3 plus 4i. So like the same problem, the complex conjugate would be 3 minus 4i, the sum would be 6 and product would be 25. So the equation would be x square minus 6x plus 25 is equal to 0. Question 303 says that if one root of the equation 4x square plus 2x minus 1 is equal to 0 be alpha, then prove that the second root is 4 alpha squared minus 3 alpha. So roots are given by minus 2 for the b term plus minus square root of 4 plus 16 by 6. That is minus 1 plus minus square root of 5 by 4. Now square root of 5 minus 1 by 4 is cos 72 degree and square root of 5 plus 1 minus square root of 5 plus 1 by 4 is minus cos 36 degree, which is equal to cos 216 degree. Okay, and I don't know what is this 3.72 degree. Now 3 into 72 degree, that is not 3 point, this is 3 multiplied with 72 degree. So we know that cos 3x is equal to 4 cos cube x minus 3 cos x. So this is cos 3x and this is cos x. So clearly if one root is alpha, the other would be 4 alpha cube minus 3 alpha. Question 304 says that if alpha, excuse me, if alpha is not equal to beta and alpha square is equal to 5 alpha minus 3, beta square is equal to 5 beta minus 3, form the quadratic equation whose roots are alpha by beta and beta by alpha. So alpha beta, if you see, are the roots of the equation x square minus 5x plus 3 is equal to 0. Because if you bring all to the left hand side, it will become alpha square minus 5 alpha plus 3 is equal to 0. And similarly, beta square minus 5 beta plus 3 is equal to 0. Alpha beta will be roots of the equation x square minus 5x plus 3 is equal to 0. So alpha plus beta will be 5 and alpha beta will be 3. Now alpha by beta plus beta by alpha is alpha square plus beta square by alpha beta is equal to 5 into alpha plus beta minus 2 alpha beta by alpha beta, that is 19 by 3. Question 305 says that in copying a quadratic equation of the form x square plus px plus q is equal to 0, the coefficient of x was wrongly written as minus 10 instead of minus 11 and the roots were found to be 4 and 6. Find the roots of the correct equation. So correct value of p is minus 11. Q is 4 into 6, 24. Therefore, the correct equation is x square minus 11x plus 24. So the roots are 8 and 3. Question 306 says that in writing a quadratic equation of the form x square plus px plus q, the constant term was wrongly written as minus 6 in place of 2 and the roots were found to be 6 and minus 1. Find the correct equation. Here the correct value of p is 5 and correct value of q is 2. P is sum of roots. Okay. Hence the correct equation is x square minus 5x plus 2 is equal to 0. Next, we have two candidates attempt to solve a quadratic equation of the form x square plus px plus q is equal to 0. One starts with, there is single I, starts with the wrong value of p and finds the root to be 2 and 6. The other starts with the wrong value of k and finds the roots to be 2 and 9. 2 and minus 9. Find the correct roots. So, for the student with correct value of q, 6 into 2 is equal to 12. Okay. So, q will be 12. From the second student, the correct value of p is minus of 2 plus minus 9, that is 7. Hence, the correct equation. The second roots are 2 and minus 9. So, sum would be minus 7. This should be minus 7. So, the correct equation is x square plus 7x plus 12 is equal to 0, giving us 3 and 4 as the correct roots. Question 308 says that if alpha beta be the roots of the quadratic equation x square plus px plus q is equal to 0 and alpha 1 beta 1 be the roots of the equation x square minus px plus q is equal to 0, form the quadratic equation whose roots are 1 by alpha 1 beta plus 1 by alpha beta 1 and 1 by alpha alpha 1 plus 1 by beta beta 1. So alpha plus beta is p, alpha beta is equal to q, alpha 1 beta 1, alpha 1 plus beta 1 is equal to p, alpha 1 beta 1 is equal to q. Now there are some typing mistakes here. Okay. So 1 by alpha 1 plus 1 by alpha beta 1 plus 1 by alpha alpha 1 plus 1 by beta beta 1. There is massive typing mistake here is equal to, now you take LCM, you get alpha plus beta on top into alpha 1 plus beta 1 divided by alpha 1 beta 1, that is PQ by QP, which is 1. Now product of roots, if we try to find, you can see how it is simplified, and you follow this, the answer would be, for this is p cube plus q cube minus p cube by p square q square, that is the product of roots. So the equation is x square minus x plus p cube plus q cube minus p cube by p square q square is equal to 0. Question 309 says that if 2 plus root 3i is the root of the equation x square plus px plus q is equal to 0, where p and q are real, then find them. So complex conjugates appear in pair, complex roots appear in pair. So 2 plus root 3i is one root, then other would be 2 minus square root of 3i. So sum of roots would be minus 4 and q would, product of roots would be 13. So here you have to take a sum of roots is actually 4, okay, while putting the sign changes, okay. So x square minus 4x plus 13 is equal to 0. Similarly over here also, while putting the p, the sign changes, okay. Question 310 says that find the equation whose one root is 1 by 2 plus square root of 3. This is an irrational root, so this will also appear in pair. So the other root would be 1, so 1 by 2 plus root 3 is 2 minus root 3. So other would be the conjugate of this, that is 2 plus square root of 3. Sum of roots is 4 and product is 1. So the equation would be x square minus 4x plus 1 is equal to 0. So there are typing mistakes in 308 and 307. I'll fix this problem in the PDF. So with this, we come to the end of 31st set of problems on quadratic equations and polynomials. I hope that you are enjoying this series of videos and finding it useful for your studies, exams, concepts, and practice. And do not forget to subscribe to the channel if you have not already subscribed, like the video, and make use of comment box for, say, pointing out the errors or whatever you have to say. You can make use of comment box, and if you have any doubts also, please make use of comment box. I will try to reply to each of your comments. So thanks a lot for watching the video. Enjoy.